Hey everyone, the topic I chose to discuss a little bit more from this chapter are IOCs, or indicators of compromise. So indicators of compromise would be things that you can see or observe on your computer or your network if an attack or a compromise has occurred or is potentially ongoing. Now, when I think of indicators of compromise, I typically think of things that I can access or go to or again observe on the computer, like IP addresses, domain names, file hashes, those sorts of things. And then these are things that we can also search for on our network if we have the appropriate tools, or search for on our computers if we have the appropriate tools. And so I just thought I would kind of walk through a little bit of a sort of an investigation type process that you might encounter. Now, I realize this course isn't trying to teach you to be a cybersecurity analyst, but it is important to understand if we're putting up defenses or we're in charge of an organization and we're part of the IT department or cybersecurity department, some things we would want to be aware of and some things that we would want to um, be on the lookout for. So what I have here is a website called Hybrid Analysis. And before I get into this maldoc.bin, hybrid analysis is what I would refer to as a sandbox. What hybrid analysis does for us is it takes a file or a website or a hash or something like that, and it analyzes it for us. It puts it into a virtual machine, opens, in the case of a file, it opens up the file, it runs the file, it looks to see what it does, and all of these different things. And so, for example, here I can put in a file or a URL. So if I have a website that maybe I went to and I think, oh, it's malicious or it has malware attached to it, I can put that here. If I have a file, I can upload it here. File collections, if I have an entire collection, I can put that here. If I want to search for an already known indicator of compromise, like an IP address or a domain or a file hash, I can put that in here and search for it. Yara is a threat hunting rule set that I can use to look at a byte level in terms of network traffic or file traffic. I shouldn't say file traffic, but the file makeup down to the bit level to see if that is malware. And I can also do a string search where I can match strings or hex patterns. Um, you can also get file samples from here. So if you wanted to, get some malware and put it on a VM and take a look to see, what it's doing and what it does, then you definitely can create an account and download this. Just be careful with how you work with those files. You want it in a separated VM that doesn't have access to the internet or to your other machines or things like that. So what I have here, this is an old file, but um, it will serve as a good example here. This is a file that was attached to an email. So imagine a scenario where somebody gets an email and that email has an attachment and they think it's just a normal Word document, and so they download it, they double click on it and open it, and all of a sudden their computer's infected. All right, so now us as the cyber defense team has to kind of kick into action. We want to, separate that machine off the network. We want to analyze that machine to see what type of malware it is. Did it spread? What are the indicators of compromise of that machine? And so what I did with this hybrid analysis is I uploaded the file, and I'm going to just skip down here. We'll come back because the picture paints 1,000 words. And so I again downloaded that file and I uploaded it to hybrid analysis, and it put it inside of a Windows 10 machine because this is an older file. And then it double clicked and it opened up the file, and it happened to open up in Microsoft Word version 2010 and this particular VM. And as you upload samples, you can choose the machine you want to run the sample in. Is it going to run in a Windows 11 machine? What Office version does it have? Is it a Linux machine? Those sorts of things. And then it's just taking screenshots of what's happening as that file was being run and opened and executed. All right, so what's important to us now are these indicators of compromise. So we know now that this file is malicious. We got a 100% match. Antivirus 73% there has flagged it as being a virus. There's another website I'm going to take you out to real quick, and this is Virus Total. Virus Total is a tool that you can use for URLs, IP addresses, files again, to see if something is considered malicious. I can't remember if I showed it in this video or if that was for a different class, but what I could do here is I could take a file and I could upload it, and then what it's going to do is it's going to analyze it amongst many of the various antivirus programs that are out there. So you're going to see Avast, you're going to see Norton, you're going to see CrowdStrike, you're going to see Kaspersky, and it's going to give us an idea of whether or not this file is malicious. Now, the other thing that it does is it gives it a file hash. And if you're not familiar with what a file hash is, it's a mathematical algorithm that's run on a file, and only this file is going to have this particular hash. No other file in the world is going to have this particular hash. If I went and just altered one little bit or a byte inside of that file, I would get a new hash. But let's pretend that this engineering number one PNG file is in fact malicious. It has malware attached to it. Well, now I have an indicator of compromise. I could search my network for this particular file hash and see if any other computers also downloaded that particular file. So when I was out in the field working as a cybersecurity analyst, we had a tool from Palo Alto Networks, and all of our machines were connected to that tool, and we could do searches on the entire network for particular IOCs. And so we could just do a search for this hash to see if any other computers had it. Now, we won't want to search on the file name because I can name any file this particular name, but only this particular file with the malware would have this hash. So going back to this maldoc.bin, so someone downloaded it, opened it up out of an email, and it comes back and it tells us malicious. Now along the right hand side, I can see all of the different things that it's doing for us. I already showed you the screenshots, but then there's the indicators. So here are some malicious indicators of compromise. It created a process using wscript.exe. It opened up PowerShell, and then it ran this, I don't remember if that's encrypted or if that's just like base64. But it's doing something. Typically files, especially Word files, shouldn't open up PowerShell and do something else. What else is it doing here? It's spawning new processes. It is trying to write data to a remote process. And so again, these are indicators of compromise. Typically machines don't do this. I could search other machines for these indicators of compromise. It's also very suspicious, which help lead it to its 100 out of 100 malicious score. It's doing some suspicious things, things that files typically don't do. So it's trying to hide a payload in the command line. And so this is exactly, it looks like it's using a base 64. And so what I could do is I could kind of reverse engineer this, so to speak. I could take this and I could reverse engineer it to actually get the string from base 64 to something readable. And then again, we have an indicator of compromise. Maybe this base 64 string is telling the machine to go out to a URL and to download something, or go out to a command and control server and check for the next command. Here it found an IP and a URL, kind of along those same lines, or Crimical, or salesleam.com, whatever that happens to be. These, number one, don't have HTTPS, so we know that they're not secure sites. And then, they could potentially be infected. So what I would want to do now, given this scenario as a cybersecurity analyst or a defense team, is I would probably go out to my firewall and I would go to my block list and I would block these particular URLs so that no one can go to them. Again, I would probably do a search for the file hash Oh, and the file hash is in here somewhere. I saw it back on virus total, but it's also on hybrid analysis here. I would do a search for that. Here it is. Here's that hash. I would do a search for this hash on my network to see if any other machines happen to be infected. I would take a look at any other indicators of compromise, and I would be doing searches. I would be doing blocks. I would be doing investigation on those particular IOCs. Now, when it comes to IOCs, a lot of times attacks are network based. So if we can get to go back up here. If we can get to something tangible like this, IP addresses, domain names, file hashes that are being downloaded or even uploaded on the network, now again, we can go put in defenses and we can go put in blocks for those. So it's always kind of this cat and mouse game. Now, as a cyber defense team, you can also subscribe to services that will provide IOCs for you. Known bad IP addresses, known bad domain names, known bad file hashes. That's sort of how antivirus signatures work, sort of how firewall signatures work. But we can then plug those in to like dynamic lists, as they're called, into our defense tools. So now our defense tools now know to look for these IOCs. So IOCs are huge for us with, especially an investigation on a cyber defense team. Here's 3 processes it analyzed. So it found the winword.exe because it was a Microsoft Word file or masquerading as a Word file. And so that's what it was. Then what that did is it spawned off a Windows script.exe, and then it spawned off PowerShell and this encrypted PowerShell command, because we can't quite read it, did this. So it sort of tried to decrypt it. It's going to create a new object. It's going to do some compression. It's going to deflate it. It's going to take a look at the memory stream. It still isn't quite readable because now it's in a base 64. But again, I could take this into base 64 converter, and I could then potentially see what it's doing. But again, IOCs, indicator of compromise. Those are some things that we can look for on our network to verify whether or not machines have been infected or are under attack. Just real quick, I'm going to go back out to the home page of hybrid analysis here. Under sandbox and files, there's a wide variety of files of other submissions from other users. And so I'm just going to go into this red line stealer. It was rated 100 out of 100, 77% of antivirus engines detected it. And again, I could take a look at some of these indicators. I like to sort of just go all the way to the bottom. To start, it's a little bit easier for me to kind of get a grasp of what's going on. It turns out to be an executable for Microsoft Windows. Here is the file hash, so there's an indicator of compromise. It was written in C++ on 2022. What else do we have here? Here's the file name, so another indicator of compromise. Let me scroll down below this. Here's the screenshots. Here are some other processes it spins up or spawns up. So here's another indicator of compromise. These are things I could look for on a machine to see if they also have that. Here's a bad IP address because it contacted that. Here's the port it contacted it over. Another executable, the country that it hit. So again, these are all different things that I could look for on a network for indicators of compromise. So take some time, create an account on here if you get a chance. Take a look at some of the files and URLs and just kind of take a look at what it gives you. Now this is just one of many. There's Joe's Sandbox, Cuckoo's Nest is another one. Those are all free. There's also paid versions out in Enterprise. Maybe you're looking at CrowdStrike or some other paid service that can do some of this analysis for you. That's all for this video. I hope you found it informative and maybe it sparked your interest into, how some of this analysis is done and how we, look for particular indicators of compromise on a network. Thanks for watching.